Welcome to Computer Science Engineering stream. We are seeing a series of lectures in the subject problem solving and Python programming. This subject has a subject code of GE 8151. This subject is for BE students studying their first semester degree program. In this subject we have a syllabus. Unit 1 comprises of algorithmic problem solving. Here we have many different topics: algorithms, building blocks of algorithm, statements, state control flow, functions, notations, pseudocode, flowchart, programming languages, algorithmic problem solving, simple strategies for developing algorithms, iteration, recursion, and some of the examples. In today's session we will be seeing only about the algorithms, and then about the building blocks of algorithms, and then the notations of algorithms. So as the contents of the session are, we will see what an algorithm is, how the name algorithm was coined, what is the definition of an algorithm, what are the characteristics for a good algorithm, and then what are the building blocks of an algorithm, and what are the notations of an algorithm, and what are the guidelines that are required for writing an algorithm. We will also see few examples of writing an algorithm, and then we will summarize this session. How the term algorithm was derived. The term algorithm was derived from the name of Muhammad al-Khwarizmi. He is a Persian mathematician in the 9th century. Al-Khwarizmi, and then it came down to algorithmus. Algorithmus, it is a Latin term which means algorithm. So this is how the name algorithm came into effect. So this lecture series is common to everyone irrespective of the groups, and I will see to that the session is becoming more and more interesting. Now let us see the definition of an algorithm. What an algorithm states about. An algorithm is a well-defined computational procedure consisting of a set of instructions that takes some value or set of values as input and produces some value or set of values as output. An algorithm is a procedure that accepts data, manipulates them following the prescribed steps so as to eventually fill the required unknown with the desired value or values. Now here, what is a data? A data is a raw facts. Few people they used to say it as datas, but the term datas is wrong. The plural is said to be data. Then what is the singular of data? It is datum. So my dear students, here on there is the plural of data is data, the singular of data is datum. There is no word called as datas. Hope you will not be making any mistakes in it. Fine. So here the input value we give it as a data, and then it produces some value or set of values as output. Now here in between the data that you give it as an input and you get the desired output. When you are going to feed the data, it is going to do some sort of processing, right? How will the process be done? It will be done based on certain logics. So how is the logic being developed? For developing the logic we require such a kind of algorithm, and based on this algorithm your input data will get processed and you get the correct or the desired output that has been expected. So this algorithm stands in the center between the input and the output, and that is the reason I have stated here something like this: input, algorithm, and output. So here in the input you give some data. My dear students, data is a plural. Data means raw facts. You give some data as an input in the algorithm. By using this algorithm it will get processed and you get the output. Next is, let us see the characteristics of writing a good algorithm. Whenever we are going to write anything, it should look good, it should have a good characteristics. So let us see the characteristics for writing a good algorithm. First characteristic is said to be precision. What do you mean by precision? The steps are to be precisely stated. What do you mean by stated? It should be precisely defined. What are you going to do? How you are going to do? So that step you have to define it precisely. So as a precision, as a first characteristic precision, the steps are precisely stated. As a second characteristic, it is uniqueness. Results of each step are uniquely defined and only depend on the input and the result of the preceding steps. Then what is the third characteristic? Finiteness. What do you mean by finiteness? The algorithm stops after a finite number of executions are executed. So what do you mean by the algorithm stops after a finite number of instructions are executed? What does it mean? There will be a specific input. If you are going to give input, anything and everything will have a defined time. It will not prolong on its own. Anything and everything has a life cycle, has a lifeline. So if you are going to give an input, it will be doing some processing, you will be getting a desired output. But here, for that, for getting the output, there is a time limit. If it is going to exceed the time limit, you will be getting an error or a pop-up message stating that out of bounds error or timeline exceeded. Likewise, you will be getting many different errors. So that is one of the characteristics. Finiteness. The algorithm stops after a finite number of instructions are executed. Then what is the fourth characteristic of a good algorithm? Effectiveness. Effectiveness means algorithm should be most effective among many different ways to solve a problem. Whatever algorithm that you write, it should be effective and it should be efficient. So you cannot write the pages together as an algorithm. The algorithm should be precise and it should be effective. Fifth characteristic of a good algorithm is input. The algorithm receives input. Then what is an output? The algorithm produces output. Next characteristic, the final characteristic is generality. The algorithm applies to a set of inputs. What do you mean by set of inputs? That input whatever you give, we will be seeing it in the near future when we are doing the coding part. As far as the Python program is concerned, when we are doing the coding part, you are supposed to give a specific set of inputs to get a desired output, and the input that you give, it should be generic in nature. That is what the generality characteristic defines. It states the algorithm applies to a set of inputs. So my dear students, these are said to be the characteristics of good algorithm. I repeat, the characteristics of good algorithm are precision, uniqueness, finiteness, effectiveness, input, output and generality. These 7 points specify the good characteristics of an algorithm. Then next is about the building blocks of an algorithm. An algorithm has been built based on 4 different blocks. The first block is said to be instruction, second is state, third one is control flow, fourth one is functions. I repeat, the building blocks of an algorithm are instructions, state, control flow and functions. Now what is an instruction? What do you mean by an instruction? When you are going to in your schooling, your teachers would have given certain instructions to complete the homework. She would have said, by tomorrow morning 9 o'clock you are supposed to submit all your homeworks and it should be kept on my table, on my desk. That is an instruction received from the teacher. So let us see how the instructions are being kept in this computer. The instructions describe a computation that when executed proceeds through a finite number of well defined successive states, eventually producing output and terminating at the final ending state. The transition from one state to the next is not necessarily deterministic. That algorithms, such an algorithm, you call it as randomized algorithms. That is, as an instruction, when there is a transition from one state to the other and which is not necessarily deterministic, such algorithms you call it as randomized algorithms. Then the instruction is a single operation that describes computation. Whatever computation that you do, that is an instruction. It is a single operation. The instruction, when executed, it converts from one state to the other state. Madam, your teacher, she would have given you an instruction to submit the homework. That is what you are supposed to do then. You are supposed to, in your home, you are supposed to sit and write your homework, complete it, close your notebook, the very next day come to the school, place the notebook on the table, because the instruction given was submit the notebooks to at my desk sharp by 9 a.m. So you are supposed to complete the homework and then submit. You are not supposed to submit a blank homework notebook. So the instruction is a single operation that describes a computation. So this is what an instruction is. Then what is the next building block? The second building block is said to be state. What is a state? The state of an algorithm is defined as its condition regarding stored data. The stored data in an algorithm are stored as variables or constants. The state shows its current values or contents. So this state, it gives the what sort of condition you are going to implement. Then what is the third building block of an algorithm? The third building block of an algorithm determines the functions. What is a function? For complex problems, our goal is to divide the task into smaller and simpler tasks. Such a simpler task, you call it as function. Where do you divide it? During algorithm design. A set of related sequence of steps which is part of a larger algorithm is known as functions. Here, say for example, in your home, your mom or your dad ask you to deposit some amount in the bank. What do you do then? That is a task that has been given to you. You go directly to the bank, you deposit the amount and you come out. Is that you do? You go to the bank, you divide it into smaller steps. How do you do it? You go to the bank, ask for a pay-in slip, deposit challan, then the banker gives the deposit challan to you. You take your pen, you start filling the deposit challan and then you submit it to the cash counter along with the amount, mentioning your SB or current account number and the branch. Then you give it to the cash counter. The cashier checks the amount. If it is correct, and he will deposit in the account number that you have specified, and then he will put a seal and he will give you a counterfoil. Then you come home, you give that counterfoil to your mom or dad. What was the instruction given to you? The instruction given was deposit 10,000 rupees in the bank in my account. That was the instruction given. But what was it? That was a task that was given. What did you do? You split those tasks into subtasks. So each and every smaller and simpler task, you make it as a function during this algorithm design. My dear students, you will understand it even more clearly when we are going in for the coding part. Now, what is the other building block of an algorithm. The final building block of an algorithm is control flow. What is a control flow? Control flow is also called as flow of control. The flow of control is the order in which individual statements, instructions or function calls of an algorithm are executed or evaluated. The algorithms, usually you have three different control flows. What are those three different control flows? One is called a sequence, second one is selection, third one is iteration. So now let us see what a sequence control flow is. A sequence control flow is a sequence is a series of steps that occur one after the other in the same order every time. What does it mean? A sequence is a series of steps that occur one after the other in the same order every time. We will explain this we will see this with an example too. Then the second type of control flow is selection. A selection is a decision that has to be made. A selection is a decision that has to be made. The third type of control flow is iteration. Iteration is also called as repetition, which means a set of steps which are repeated over and over until some event occurs. Now let us see these three types of control flow with an example. The first type of control flow is called a sequence, second is selection, third one is iteration. Now you have a car. Let us consider you have a car. Hope few people would have learned driving, or let us also consider you have a bike. Hope many people might be knowing how to ride a bike. Okay, either bike or car, you have it. Now you are asked to drive from one place to the other place. Say for example, you are asked to drive from Chennai to Pondicherry. Let us consider Chennai to Puducherry. Here what happens is that when the road is clear, when there is no signal at all, when there is no human intervention at all, then when there is no cattle intervention at all, like bulls or cows or goat or sheep, when there is no intervention and when the road is highly clear, what do? If you are going to drive a car, you start, you ignite the vehicle, you start the you put the key and you start the vehicle, you give a first gear, you take up the clutch and you press the accelerator. When you move few steps ahead, you change from the first gear to the second gear, then move ahead, then put the third gear, then move ahead, then put the fourth gear, then move ahead, then put the fifth gear, then move ahead. So when you are in the fifth gear or the top gear, your car will reach the maximum speed limit, which means it is a sequence, it is a series of steps that occur one after the other in the same order every time. And when you are going to stop, you will stop from fifth gear to neutral gear. So at the start itself, you will not be starting to drive the vehicle from the fifth gear onwards. So you will, from the start, if you want to start, you will start from the first gear, slowly go on to second gear, slowly go on to third gear, slowly move on to fourth gear, then move on to fifth gear, then stop when the destination is reached. This is how you do on a step by step basis and on a series, and you follow a series of steps. This is called as sequence. Then the next one is called as selection. Okay, fine. Now you are driving a car, you are listening to music, when there is suddenly when you could see a signal, and usually you might be knowing in the traffic signal there will be three lights. One is a red light, amber light is said to be an yellow light, third one is the green light. You are supposed to cross the signal one and only you have a green light, or you have an yellow light, the amber light. What does it mean? It means you should be cautious, ready enough to know whether you are going to stop or whether you are ready to start the vehicle. Supposing if you are driving the car and you find an yellow light, yellow signal, the amber signal that has been glowing, what do? Either you, usually the youngsters, the young blood, what people do is, before the red light comes in, they will try to cross the signal. But few people, the older people, when there is an yellow light, amber light, they will slow down the car, they will stop at the signal, and they will start only when the green light is turned on. So this is what the selection determines. In this selection, when there is yellow light, you are going to decide whether you are going to stop your vehicle in the signal or whether you are going to speed up your vehicle and you are going to cross the signal before the red light glows on. So this is called as selection. What you are going to do. Now you are understood with sequence and selection. Now we will go on to iteration. Supposing if you have stopped your car in the red light and you are waiting for the green light to come in. So while you are waiting, your mobile phone rings. So now you are idle, you are idly sitting waiting for the green signal to be on. Now say for example, in your car your mobile phone rings in. What you do is, you will be having an you will be checking, or let us also consider, many people have a habit of checking the WhatsApp when they are free. So when the red light is on, when you are in the signal, many people have an intention to check the WhatsApp. So when you are checking the WhatsApp, what happens is that you will also check whether the signal is turned from red to green. So you will be seeing the signal, then you will be checking the WhatsApp, then you will be seeing the signal, then you will be checking the WhatsApp. So you are doing a repetitive process. Such a kind of repetitive process, you call it as iteration. The iteration is also called as repetition, which means a set of steps which are repeated over and over until some event occurs. You are checking the WhatsApp until you get the green signal turned on in the traffic signal post. So you will be checking WhatsApp as well, you will be checking the signal line. So that is what the repetition or iteration means. Hope it is clear. So these are the three types of control flow. And now let us see the notations of an algorithm. There are 4 different kinds of notations to represent an algorithm. One is called as step by step form, or it is also called as step form. Second one is called as pseudocode. Third one is called as flowchart. Fourth one is called as programming languages. So now let us see in detail one by one. Step form or step by step form. Before we could see the step by step form, we will as well see what are the guidelines for writing a good algorithm. Algorithm is a step by step process. You need to start the algorithm either with begin or with start to start the process. To start the algorithm, you need to write either begin or start to start the process. Then you need to include variables and their usages. Then if there are any loops, you need to give sub number list. You need to try to go back to step number if it is a loop or condition, and if the condition fails, it should go to a specific step number. Then you are supposed to use jump statement to jump from one statement to the another statement. Then you need to try to avoid unwanted raw data in algorithm, and you are supposed to define expressions. You need to use break and stop to terminate the process. My dear students, hope you would have been clear with the guidelines for writing an algorithm. An algorithm is a step-by-step process. It is step-by-step process is one of the notation of an algorithm. As we have seen, it is the first notation of an algorithm as step form. So algorithm is a step-by-step process. While you are starting, you are supposed to start with either with begin or you are supposed to use start, and then you are supposed to include variables and their usage. If there are any loops, you are supposed to give sub number list. If you want to go back to a specific step number, if the loop or if the condition fails, you are supposed to give step number. You are supposed to use jump statement to jump from one statement to another. You are supposed to avoid unwanted raw data in an algorithm, and you are supposed to define expressions. You are supposed to use either break or stop to terminate the process. So this is an example for writing a step-by-step process. Then we will see an example of writing a simple algorithm. As I said, it has a step-by-step process. So step-by-step process means we write it in step numbers. So step 1, start. Okay, let us see an example for finding the biggest number of the 3 numbers. You take any 3 numbers, you need to say which number is said to be the biggest number or the largest number or the greatest number. So step 1, how do you start the algorithm? Either you need to write start or begin. So step 1, start. You are supposed to read the variables. That was the guidelines that was given. So read the 3 numbers a, b and c. Step 3, compare a and b. If a is greater, perform step 4, else perform step 5. Now what is step 4? Compare a and c. If a is greater, write the output as a is greater, else write the output as c is greater. Then go to step 6. Now step 5, compare b and c. If b is greater, write the output b is greatest, else the output c is greatest. Then go to step 6. What is step 6? Step 6 is stop. Why do you need to stop? When you have started, you are supposed to stop. This is one of the characteristic of writing a good algorithm, finiteness. When you are going to start, you are going to give a stop. After you start, you are reading the 3 variables a, b, c. Then in the steps you are comparing. Now this is an example for finding the greatest of 3 numbers. Now let us see the second example, how to effectively, because effective writing is also one of the characteristic of an algorithm. The algorithm should be precise, should be crisp, should be small, and it should be effective. So let us see how to cut short few lines on this. This is the example 2 of writing a simple algorithm. Step 1 is start. Step 2, read the 3 numbers a, b and c. Step 3, compare a and b. If a is greater, store a in a variable called max, else store b in max. Step 4, compare max and c. If max is greater, output is max is greater, else output c is greater. Step 5, stop. In the previous example, you had 6 steps, now you have only 5 steps. The example 3 is to write a simple algorithm with certain loops. Now listen to the logic alone, just see the steps alone. It is for finding the marks total, and then how do you get the output. So you are reading the number of subjects, and in the step 4 you are trying to type in each and every marks, and you are going into step 5 and you are totaling the marks, total equal to total plus mark. Step 6 is you are reading the next marks. So we are incrementing I equal to I plus 1. Step 7, if I is less than or equal to n, then go to step 4. What is step 4? Again type the marks, enter type in the marks, otherwise go to step 8. What is step 8? Total the output the total. So, total equal to total plus mark. Step 9 is stop. Now, what have we inferred from these 3 examples? Example 1 and 2, in step 1 and step 2 are in sequence logic. What is step 1 and step 2? Step 1 was start, step 2 was you are giving variables, you are declared variables. So, step 1 and step 2 are in sequence logic. Step 3, 4 and 5 are in selection logic. You will be remembering the example of car driving. So, step 3, 4, 5 are in selection logic. In the example 3, step 7 have to move to the statement with a backward step reference. So, it is an iteration logic. In step 7, as far as example 3 is concerned, if I is less than or equal to n, then go to step 4, it is going to a backward, otherwise go to step 8. So, as it is going to backward, we are seeing it as an iteration logic. Now, let us summarize this session. What are things we saw? We saw how the term algorithm was derived, we gave the definition of algorithm, we saw the characteristics of a good algorithm, we saw the building blocks of an algorithm, instruction, state, control flow and functions. We saw about the notations of algorithms, step by step, pseudocode, flowchart, programming languages. In this session, we have seen only the first step by step notation of an algorithm, and then we saw the guidelines for writing a good algorithm with certain examples. Thank you.